Hi everybody, let's talk about, this is the first video in Algebra 2. It's not a review, it's just a Algebra 2 real video. The first one is graphing piecewise defined functions and shifting and reflecting graphs of functions. So this is what we're going to talk about today. Let me give you an example. The first one, defined function, and like I said, defined piecewise function. So the question is asking evaluate, and you guys already know evaluate means to find the value of. Evaluate f of 2, f of negative 4, and f of 0. Okay. For the function f of x equal, and this is my piecewise function, it's in pieces, that's why it's called piecewise function, 3x plus 1 if these are the restrictions, and we have to be very careful about the restrictions. X less or equal 0. Then another piece is x minus 4 if x is greater than 0. Now this one is included, this one is not included. Then write your results in ordered pair form. So my answers should be in ordered pair form. Ordered pair form. Okay, that will be my answer supposed to be. Now, my piecewise function, let's try f of 2. Now, do you see you have two pieces? So where the f of 2 means I'm going to, let me write it down here. This is my f of 2 is going to be, I'm going to plug in f of 2 here. In here, I'm going to draw a line. In this one, I'm going to do f of negative 4. And up here, I'm going to plug in f of 0. So we can have all three and we can see what's going on. Okay, so when I plug in f of 2, I have two pieces. So in which piece I have to plug in the x equal 2 in the function. So look at the restrictions. This is what I said, be careful about it. This one says x is greater than 0. And since I have a 2, I can have this one as x greater than 0. This one says x less or equal 0. Like if I have 0, I'm going to plug it in. Or if I have less than 0, then I'm going to plug it in this piece. But since 2 is greater than 0, then I have to use this piece of information to plug in my f of 2. So I'm going to plug in f of 2 equal x minus 4, that one. Plug it in, f of 2 equal 2 minus 4, which is giving me f of 2 equal negative 2. And they said the answer is supposed to be in the order form, so I'm going to give you answer in the order form. The x value is 2, since x goes first and y goes second, so these are my two order pairs. Let's try this one, negative 4. Now negative 4 is less than 0, so which restrictions or which piece of the information or which piece of the function I need? X less or equal 0. So since this is less, I'm going to use 3x plus 1. So f of negative 4 equal 3x plus 1. Plug in that negative 4 for x, 3 negative 4 plus 1, which is going to give me 3 times negative 4 is 12, negative 12 plus 1, that one stays. Again, f negative 4 equal, when you subtract, you get negative 11. So my order pair in this case is going to be negative 4, negative 11. Again, write this. Now we have f of 0. Okay, where 0 goes, do you see this is greater than 0 only? This one is x equals 0 or less 0. Since this is equal 0, I'm going to use 3x plus 1 again. So I'm going to plug in f of 0 equal 3x plus 1. Plug in that 0 for x. And my answer is going to be 1. Order pair is 0 and 1. So these are my answers for order pairs for this. Now, another, let's do another question where we're supposed to graph the piecewise function. And we're going to graph each piece separately, okay? So let's try that one. I'm going to move this down here because this is where I need this. Okay. Here's the example. I'm going to start. Example number 2 is talking about I have f of x equal, that's my another example, f of x equal piecewise function 3x minus 1 and x plus 3. The restrictions for this one is x less equals 0. This one is if x greater than 0. And how do we graph this? Okay, so let's make a table for each piece and plot the points. So if I pick this one first, I'm making a table for it. For example, these are all my x values going to be, and I'm going to plug them up here in 3x minus 1, right? That's my function. I'm going to plug it in here for y equal, or f of x equal, the same thing. So pick the x values. You're going to pick x values which are equal or less than 0. And I don't have to pick like a bunch of them. I just pick 3. That would be enough. So for example, they said x less or equal 0. So I started with 0. Less than 0 can be -1 and -2. So these are the only 3 I'm going to pick. Now let's plug in 0 here. If I plug in 0, 3 times 0 is 0, subtract 1 is going to give me -1. Okay, plug in -1 here. 3 times -1 is going to give me -3, minus 1 is going to give me -4. When you plug in -2 here, 3 times -2 is -6, minus 1 is -7. Okay, now let's do that one. I'm going to make a table again for that one. And in this case, I have x plus 3 y equal, and I have to pick all the numbers greater than 0. So I'm going to pick 1, 2, and 3. Okay, plug in 1 here. 1 plus 3 is going to give me 4. 2 plus 3 is going to give me 5. 3 plus 3 is going to give me 6. There you go. So I got the tables done. Now let's try and graph this. First, 3x minus 1, this piece. It says 0 and -1. So my 0 is right there. For x, -1 is this. So that's 1 point. Then I have -1 and -4. So this is -1, -4, 1, 2, 3, 4. Another point. Then we have -2, -7. So -2, -7, 1, 2, 3, 4, 5, 6, 7. Right there. So this portion is good. Now let's draw a line, and if you guys pay attention, I'm starting 0, so I'm gonna go, it's not gonna be straight, but here we go. Okay, that's my line for this graph for this function. Now let's go back and draw that one. 1 and 4. 1, 2, 3, 4. 2 and 5. 2 is x, 1 and 2, and x, y value is 5. 1, 2, 3, 4, 5. Then I have 3 and 6. I have 3 and 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, now do you see this x equals 0 or less equals 0? They said equals 0, that one. This one's supposed to be closed circle, okay? Because you know this line means when you have an inequality, you have these lines. It means you have a closed circle and included. So that's a closed circle, okay? Which is already 0, -1. I made it closed circle anyway. Okay, let's try that one. And do you see x greater than 0 means this 1 and 4, this one, this is going to be open circle. Because you see you don't have equal thing here. So I'm going to draw That was okay. So I'm gonna draw this line. We already plot the points. It's gonna go something like this. And 1 in 4. 1 in 4 is this one. Okay, that's 1, 1, 2, 3, and 4. So I'm gonna make this open circle. Okay. In the middle, I should be erasing that. Oh God. Let's. Okay. There. This is open circle. I'm not gonna touch it again because it's gonna mess up. So this is open circle. Okay, so it's gonna go in this direction. Okay. That was the graph of piecewise function. Now, you guys always memorize the parent function. It's going to help you big time. And I'm going to give you 4 parent functions today. And then memorize them. Write it down, please. The first one is y f of x equal x. F of x equal x. Or you can say y equal x, either way. Y equal x, the parent function goes like this. Okay, that's a parent function for that. For f of x equal x squared, and the graph for this one is gonna go like a parabola. It goes like that. Okay, so that's a parabola. The parent functions. These are the functions that never changes, and you can change them around if they ask you, but the parent function stays the same. And this one is gonna go in this direction, and this is the square root x. F of x equal. Memorize them. Next, I have f of x equal absolute x. And my absolute x goes like this. Okay, so these are the 4 functions for now that you have to memorize. These are the parent functions. And we're gonna, since we are doing shifting and reflecting, so you need to know the parent functions for it. Okay, let's talk about vertical shift. How do we do vertical shift? Okay. Vertical shift of the graph. Vertical shift means you go up and down, upward or downward, like on y-axis, downward. Okay, and I'm also going to write y-axis here so you know y-axis goes up and down. Then we, how do we do vertical shift and how does it look like in the function if I have, for example, I have g of x equal f of x plus k. Now, let me erase this plus k. This plus k means this portion. That's a function. If you have a constant there, okay? So this means plus k means it's going upward. K units up. So I can write here k units, whatever number is here, real number, then that many numbers you go up. K units upward. Okay, let's try g of x equal f of x minus k. Minus k when it's a constant and you have a minus there, then it means k units downward. Units downward. Okay, how do we do horizontal shifts? Now, those were vertical shifts and horizontal shifts. Horizontal shifts. This means to the left or right. And it means I'm talking about x-axis because x-axis goes left and right. Now let's see if the stuff works here. G of x is equal f x, and make sure guys you know it. It's gonna be minus h. Okay, do you see, check the difference? This is a function and it is just a constant, like all the way at the end of the question. So we go up and down. But this one, when you have a function and you do have something within the parentheses and it's go left or right or something like that, then you have a minus. This minus means minus h. That means h units to the right. You see, I'm going opposite. Like if it's minus, then I should say left. But in this case, you go to the right. Now let's see, g of x equal fx, and then you have plus h. It means h units to the left. If it's positive in this case, then it's going left. Okay, so let's try some examples for all of this that we learned. Since let's give you example on that one, okay? Now look at the example. Okay, I'm gonna graph and I'm gonna give you example. They said graph f of x equal x squared minus 3. Now that's why I said remember the parent functions. Do you see this x squared? We do have a parent function for that, and the x squared parent function is this parabola, that one. So I'm going to draw that parabola there. Okay, the parent function first, and that's what I always do, draw parent function first. That's my parent function, and this is x squared, that one. Okay, now what does this minus 3 means? Do you see this looks like this, a constant all by itself, and it's subtracting, like it's negative, then it's going to go down. So my graph that is going down is going to be 1, 2, and 3. I'm going to draw a line here. This is 3. So I'm going down 3, the graph. This graph, I shifted it vertically, and it's going down 3. That's what it means, you go up and down. So shift the this original graph downward 3 units. And you can tell 1, 2, 3 units. Okay. Now let's talk about horizontal. And the same thing, if it was plus 3, then I would go up 3. Okay. Now let me give you an example of that one. This one, for example, the question is said f of x equal absolute x plus 2. And what is absolute function, parent function? This is absolute. F of x absolute, and it's like a v. So I'm going to draw that v here, the parent function. Okay. There, that's a parent function. Okay, so if it's a parent function, then plus 2, what does that mean? Do you see this plus 2 is like inside the parentheses with the x? And if it's plus, it means I'm going left. This is plus, and I'm going left. So left 2 times. So this is 1, that's 2. So up here, my function moved horizontally to the left. So that would be my graph for this. Okay, let's talk about reflection about the x-axis. Reflection about the x-axis. Okay, if I have a graph of, the graph of g of x is equal negative f of x, for example, then it's reflecting about the x-axis. When you have this negative in the beginning of the function, it means it's reflecting about the x-axis, okay? So if I have, for example, this, okay? So watch how I'm graphing this. I have f of x equal negative absolute x plus 2, negative 1. Now, minus 1. Look at this, how I'm gonna change that, because I have upward shift, this one. This is a vertical shift, up and down, that one. And this one is horizontal reflection x-axis, and this one is horizontal shift. So I'm gonna write it down, okay? This one is, that one is, you go down, downward 1 unit, okay? 1 unit. This is 1 unit. So I'm going to draw my parent function first, and my parent function is going to be, okay, that's my parent function. I'm going to draw absolute parent function. Okay, that was this. Because I'm not a really good person to draw, but here we go. That's absolute parent function. It's in absolute x, y equal, okay? The rest of the, since it's in pink, I'm going downward 1 unit. So I'm going to go downward 1 unit. Okay, we'll do that. Then this one is since this is with the X, that's going to be a horizontal shift, that since it's positive, it's going to be left 2 units. Okay, and what about this? What does that mean? This one is when you have a negative in the beginning of the function, it means you are reflecting about the x-axis. So it's a reflection about x-axis. So I'm going to do all these 3 different reflection and shifting and upward and horizontal, all of them, and see how our graph look like for this function. So I'm going down 1 unit, so that's 1 unit. I went down. Then I'm going left 2, so 1 2, that's left 2. I'm not drawing anything, I'm just showing you. Okay, that's 2. And then I'm reflecting about the x-axis. Okay, I'm reflecting about the x-axis. So if I reflect about the x-axis, you know, it's gonna go down like this. This function is gonna flip. Okay, it's gonna go like this. It's not really on scale, but it's gonna go like that. So what did I do? I went down, I went left, and I reflected it about x-axis. This is my x-axis, and I reflect like a mirror. So this is how the graph's supposed to look like. Okay, guys. I think that's it, and see you in the next video. Thank you. Bye.